Have you ever looked up at the midday sun and felt a profound sense of safety? It hangs there, golden and steady, a burning anchor in the sky that has held us close for 4.5 billion years. We wake to its light, we sleep when it fades, and deep down, we trust it. We trust that tomorrow it will rise in the east. We trust that the earth will continue its silent glide around it, locked in a rhythm so ancient that it feels like the definition of forever. But what if I told you that this stability is fragile? What if the gravity that holds us is not a permanent law, but a temporary embrace? The universe is not a painting fixed on a wall. It is a dark ocean, vast and restless, filled with currents we cannot see, and giants that move in the silence between the stars. And sometimes those giants drift. Tonight, we are going to close our eyes and let go of that safety just for a moment to imagine the impossible. We are going to drift into a scenario where the unthinkable happens, where our sun, our planets, and our tiny, fragile home are drawn into the gravitational heart of a wandering black hole. But do not be afraid. In this story, there is no noise, no sudden crash, only the slow, mesmerizing unfolding of physics on a cosmic scale. We will watch as the familiar rules of our sky bend and break, replaced by a new geometry of light and time. So, find a comfortable place, let your shoulders drop, and let the tension of the day float away like dust in a sunbeam. Close your eyes. Let the sound of my voice be your guide through the darkness. Before we begin our journey into the event horizon, if you are finding peace in these quiet stories, a gentle like or a soft tap on subscribe would mean the world to me. It is a small gesture, quiet as a falling leaf, but it helps this channel grow and allows me to keep bringing you these lullabies from the stars. I am deeply grateful for your presence here tonight. Now, let's begin. To understand how our solar system could end, we must first understand what holds it together: gravity. It is the most familiar force in our lives, yet the most mysterious. It is the reason your head rests heavy on the pillow right now. It is the reason the oceans cling to the spinning earth. On a larger scale, gravity is the invisible leash that the sun keeps on the planets. The sun is massive, containing 99.8% of all the mass in the solar system, and its gravity creates a deep well in the fabric of space-time. We, the Earth, Mars, Jupiter, and all the rest, are simply rolling along the curved walls of that well, circling forever, unable to climb out. We are safe because the sun is the heaviest object around. In the vast emptiness of our neighborhood, nothing else competes with its pull. But the galaxy is not empty. It is crowded with the ghosts of dead stars. Most of the stars that have ever existed in the Milky Way have already burned out. Some faded quietly into white dwarfs, cooling slowly over eons. But the massive ones, the giants that lived fast and died young, ended their lives in violent supernova explosions, collapsing inward to become neutron stars. Or if they were heavy enough, black holes. For a long time, astronomers believed that black holes were stationary monsters, sitting quietly in the centers of galaxies like the supermassive Sagittarius A at the heart of the Milky Way, or locked in orbit with companion stars. But recent computer simulations and observations from the Hubble Space Telescope suggest something more unsettled. There are rogue black holes, wanderers. When a massive star collapses, the explosion is not always perfectly symmetrical. If it blows out more material on one side than the other, the resulting black hole can be kicked like a ball, sent careening through the galaxy at speeds of hundreds of thousands of miles per hour. NASA estimates there could be as many as 100 million of these isolated stellar mass black holes drifting through the Milky Way right now. They are the silent nomads of the cosmos. They have no companion stars to strip gas from, so they have no glowing accretion disks. They emit no light. They radiate no heat. They are simply invisible spheres of pure gravity, drifting through the dark, waiting for nothing, needing nothing. And because space is so vast, the odds of one passing near us are infinitesimally small. But small is not zero. Tonight, we imagine the 1 in a trillion chance. We imagine that one of these nomads has been moving toward us for millions of years, crossing the vast freezing voids between the spiral arms, its trajectory perfectly aligned with our own. How would we know it was coming? That is the most chilling part of the mystery. We wouldn't see it, not at first. A rogue black hole doesn't announce itself with a roar or a flash. It is a creature of silence. It absorbs everything: light, information, noise. If you looked through a backyard telescope at the patch of sky where it was approaching, you would see nothing but the usual field of stars. It would be a perfect camouflage. The only way we would detect it is by what it does to the light behind it. This phenomenon is called gravitational microlensing. As the black hole passes between Earth and a distant star, its intense gravity acts like a magnifying glass. Space itself curves around the black hole, bending the light of the background star and focusing it toward us. For a few days or weeks, a random, ordinary star in the night sky would suddenly become brighter, amplifying in intensity before fading back to normal as the invisible lens drifted past. Astronomers watch for these events constantly. The OGL, optical gravitational lensing experiment, project monitors millions of stars for these telltale flickers. But usually, these events happen thousands of light years away. In our story, the flickering stars are getting closer, much closer. The first sign would be a subtle distortion in the constellations we know and love. Imagine looking up at Orion or Ursa Major. The stars remain where they are, but the space between them seems to ripple. A tiny patch of darkness, no bigger than a pinhead at arm's length, begins to distort the light around it. It would look like a flaw in an old window pane, a smudge on the lens of reality. As it moves closer, this smudge would grow. It wouldn't block the stars behind it. It would smear them. The light from distant suns would be pulled into arcs and rings, known as Einstein rings, wrapping around the invisible center. It would be a moment of confusing beauty, a point of pure blackness, haloed by the warped ghosts of the galaxy. This is the event horizon approaching, the point of no return. But long before the black hole reached the planets, it would encounter the guardians of our solar system, the Oort cloud. The Oort cloud is a vast theoretical sphere of icy debris that surrounds our sun like a thick shell. It is the home of long-period comets, a frozen graveyard of the solar system's formation, extending nearly a light year out into deep space. It is so far away that the sun is just a particularly bright star in its sky. The comets there drift in slow, lazy orbits that take thousands of years to complete. They are fragile, loosely bound to the sun's gravity, barely holding on. As the black hole approaches, its gravity would touch this cloud first. It would be a silent disruption. Millions of icy bodies, some the size of mountains, would suddenly feel a new command. The gravity of the invader would override the feeble pull of the distant sun. The delicate balance of the Oort cloud would shatter. Comets would be flung outward into the interstellar void, lost forever to the darkness. But others, billions of them, would be kicked inward, toward the planetary system. This would be the first physical warning for us on Earth. Not the black hole itself, but the rain of comets. Astronomers would notice new objects appearing in our telescopes, not just one or two, but hundreds, coming from the same direction in the sky. A cosmic migration. These silent travelers, waking up from billions of years of deep freeze, would begin their long fall toward the inner solar system, their tails igniting as they approached the warmth of the sun. It would be a beautiful, terrifying fireworks display, a signal that the outer walls of our fortress have been breached. And yet, on Earth, everything would still feel normal. The wind would still blow, the tides would still rise and fall with the moon. The coffee in your cup would not ripple. This is the paradox of gravity. It affects everything equally. If you are falling, and everything around you is falling at the same rate, you feel like you are floating. You feel weightless. You feel still. The earth would continue to spin. The seasons would continue to change. But the foundation of our universe would have shifted. We would no longer belong solely to the sun. We would be caught in a gravitational tug-of-war between our familiar star and the approaching shadow. It is a strange thought, isn't it, that the sky could change so drastically, yet the ground beneath our feet feels the same. It reminds us of how limited our human senses are. We evolved to feel the wind on our skin, to hear the snap of a twig, to see the movement of a predator in the grass. We did not evolve to feel the curvature of space-time. We did not evolve to sense the approach of a singularity. We rely on mathematics, on telescopes, on the abstract language of physics to tell us what is real. And in this story, the math is telling us that our time in the sun's warm embrace is coming to an end. The intruder is not angry. It is not evil. It is simply heavy. It is mass in its most extreme form, and mass dictates the shape of space. As the black hole crosses the boundary of the heliosphere, the bubble of solar wind that protects us from interstellar radiation, the physics of our solar system would begin to unravel. The delicate clockwork of the planets, which has ticked perfectly for billions of years, would miss a beat. The orbits, which we think of as perfect circles or ellipses, would begin to stretch. The great giants, Jupiter and Saturn, would feel it first. Their massive gravity wells, usually the bullies of the solar system, would meet a power that makes them look like specks of dust. We would see their orbits shift, measuring the disturbance in millimeters at first, then kilometers, then millions of kilometers. The hierarchy of the heavens is being rewritten. The sun, our king, is being challenged. And we are just passengers on a small blue rock watching the titans dance. It brings up a deep question. What defines home? Is home the planet we stand on? Is it the star we orbit? Or is home simply a stable groove in gravity, a place where we can rest without being pulled apart? For all of human history, home has been defined by the sun. We are solar beings. Our biology, our agriculture, our mythology, everything is tied to that yellow dwarf star. But now, a new center of gravity is arriving, a dark sun, a sun that offers no light, no warmth, only a relentless, infinite pull. As we end this first chapter of our journey, let us rest in this moment of suspension. The intruder is at the gates. The Oort cloud is scattering. The comets are falling. But here, in your room, it is quiet. You are safe. The story is just a story. The gravity you feel is just the earth holding you, as it always has. Take a deep breath. Feel the air fill your lungs, extend in your chest, and then slowly release it. That breath is possible because of the atmosphere, which is held by gravity. Everything you are is held together by forces you cannot see. And as we drift toward the next chapter, we have to ask, what happens when the black hole moves past the comets and reaches the planets? What happens when the invisible hand reaches into the clockwork and begins to touch the gears? That is where we will go next. Into the realm of giants. Into the disruption of the outer worlds. Welcome back to The Drift. If you are just joining us, or if your mind has wandered off into the quiet corners of the room, let yourself settle back into the story. We are floating in the vast, silent theater of the mind, watching a scenario that is as beautiful as it is terrifying. We have left the safety of the known world behind. The invisible wanderer, a rogue black hole, born from the death of an ancient star, has breached the outer walls of our solar system. The Oort cloud has been scattered, its frozen sentinels flung into the dark or pulled into a long, glowing fall. Now, the intruder moves deeper into the realm of the giants. It drifts toward the worlds of ice and gas that have patrolled the outer dark for billions of years. Tonight, we watch the unraveling of the outer solar system, not as a disaster, but as a cosmic ballet, a slow, majestic dance of gravity, where planets are the dancers and the black hole is the new silent conductor. The first planet to feel the touch of the intruder is Neptune. To us on Earth, Neptune is a mystery, a deep blue marble hidden so far away that it wasn't even discovered until 1846, and then only by mathematics, not by sight. It orbits 2.8 billion miles from the sun, a lonely outpost where the sunlight is 900 times dimmer than it is in your backyard. It is a world of freezing winds, blowing at 200 miles per hour, faster than the speed of sound, whipping through an atmosphere of hydrogen, helium, and methane. For its entire existence, Neptune has obeyed the sun. It traces a massive, slow circle, taking 165 Earth years to complete just 1 year of its own. It is the definition of patience. But gravity travels at the speed of light. As the black hole glides closer, silently crossing the gap between the scattered Oort cloud and the planetary disk, its influence arrives before it does. Imagine standing on a moon of Neptune, looking out into the eternal twilight. You wouldn't see the black hole yet, but you would feel the change. The orbit of the great blue planet would begin to shudder. In celestial mechanics, this is called a perturbation. Usually perturbations are tiny, the subtle tug of Jupiter pulling on Saturn or Venus nudging Earth. But this is different. This is a gravitational tidal wave. Neptune's perfect, near-circular path would begin to elongate. The planet is being pulled by two masters now. The distant sun, small and bright, says, "Stay." The invisible darkness, heavy and close, says, "Come." And because gravity weakens with distance, the side of Neptune facing the black hole feels a stronger pull than the side facing away. This differential force, the tidal force, begins to stretch the planet itself. The atmosphere, those deep bands of blue clouds, would bulge. The winds, already ferocious, would shift patterns, churning into new, impossible storms. We are watching the destabilization of a world, and yet, in the silence of space, it makes no sound. It is a pantomime of immense energy. As Neptune is dragged off its course, its moons, Triton, Proteus, Nereid, are thrown into chaos. Triton, which orbits Neptune backward in a retrograde loop, might be stripped away entirely, flung into the void to become a wanderer itself, or crushed by the conflicting gravities into a ring of dust. The order of the outer solar system, stable for 4 billion years, is dissolving into entropy. But as the black hole feasts on the debris of the outer system, a change occurs. The invisible wanderer begins to glow. A black hole, by definition, allows no light to escape. But the mess it makes, that shines brighter than 1,000 suns. As comets, asteroids, and stripped gas from the outer edges fall toward the event horizon, they don't just drop straight in. They swirl. They spiral like water draining from a bathtub, forming a flat, spinning structure called an accretion disk. Friction in this disk is unimaginable. The particles rub against each other at significant fractions of the speed of light, generating heat, immense heat. Millions of degrees. So, for the watchers on Earth, a new star would seem to ignite in the constellation of Capricorn or Aquarius. It wouldn't look like a star, though. It would look like a ghostly eye, a central pupil of absolute darkness, the shadow of the black hole itself, surrounded by a swirling iris of superheated plasma, glowing in X-rays and ultraviolet light. It would be beautiful, a terrible jewel placed in the night sky, growing brighter night by night. This is the moment the threat becomes visible. The abstraction of math becomes the reality of light. We would see the monster that is eating the dark. Moving inward, the black hole approaches Uranus. This pale cyan world, tilted on its side, rolling like a ball around the sun, is the next casualty. Uranus is lighter than Neptune, less dense, a fluffy ball of ice and gas. The black hole's gravity treats it like a toy. We might see the planet's orbit tilt wildly, pulling it out of the ecliptic plane, the flat disk where all planets live. Imagine looking at a model of the solar system, flattened on a table, and watching one marble suddenly lift off the table and spiral upward. That is what happens when a rogue mass disrupts the plane. The solar system loses its flatness. It becomes a three-dimensional wreck, and then the king feels it. Jupiter, the protector, the massive gas giant that has shielded Earth for eons by absorbing comets and asteroids with its immense gravity. Jupiter is 318 times more massive than Earth. It is the gravitational anchor of the planetary system. But against a black hole, even Jupiter is nothing more than a moth flying toward a lantern. The black hole we are imagining might have the mass of 10, 20, or even 100 suns. As it draws near, Jupiter's orbit, the steady 12-year heartbeat of our system, would stretch. The great red spot, a storm that has raged for centuries, might distort or vanish as the planet's atmosphere is pulled into an egg shape. This is where the fear on Earth would truly begin, not because the black hole is touching us yet, but because the clockwork is broken. We have relied on the stability of Jupiter and Saturn to keep the asteroids in the belt between Mars and Jupiter in check. These thousands of rocks are held in place by delicate gravitational resonances. As Jupiter is dragged off course, those resonances shatter. The asteroid belt would be unleashed. It wouldn't be a targeted attack. It would be a shotgun blast. Rocks the size of cities would be sent tumbling into the inner solar system, crossing the orbits of Mars and Earth. The sky would fill not just with the glowing eye of the accretion disk, but with the silent streaks of meteors, the debris of a broken order. It makes us wonder, doesn't it? How much of our safety is just luck? We live in a quiet neighborhood of the galaxy, in a quiet time, circling a quiet star. We assume this is the normal state of the universe, but the universe is violent and dynamic. Peace is the exception, not the rule. We are like a small boat floating in a calm lagoon, unaware that just beyond the reef, the ocean is raging. The arrival of the black hole is simply the ocean coming in. And yet, there is a strange peace in accepting this. To realize that we are part of a much larger, much wilder system is to let go of the illusion of control. We are passengers, We always have been. The pilot is gravity, and the destination has always been a mystery. As the black hole moves deeper, passing the orbit of Jupiter, the sun itself begins to react. The sun is a fluid body, a ball of plasma held together by its own weight. As the black hole approaches, the sun would feel a tidal pull, just like the oceans of Earth feel the moon. But this tide would be monstrous. The sun would stretch. Its perfect spherical shape would distort into a slight oval. This distortion would change the fusion rates in its core. Solar flares and coronal mass ejections would erupt with a frequency we have never seen. The sun would scream in electromagnetic waves, blasting the solar system with radiation. On Earth, the auroras, the northern and southern lights, would no longer be confined to the poles. They would bleed down toward the equator. The night sky over Paris, New York, and Tokyo would be painted in curtains of green and violet, shimmering and dancing. It would be a haunting sight. The glowing eye of the black hole on one side of the sky, and the hysterical beauty of the auroras on the other. A world bathed in the light of its own undoing. And through it all, the silence. Space does not carry sound. The tearing of planets, the crushing of moons, the screaming of the sun. It all happens in absolute vacuum silence. If you were floating in a spacesuit between Mars and Jupiter, watching this unfold, you would hear only your own breathing, in and out, in and out. The contrast between the violence of the event and the quiet of the observation is the essence of the cosmic experience. It reminds us of the words of Pascal, who looked up at the night sky and said, "The eternal silence of these infinite spaces frightens me." But tonight, let's turn that fear into awe. The silence is not empty. It is full of presence. It is a canvas upon which the universe paints its masterpieces, even the destructive ones. As the accretion disk grows, fed by the gas of the outer giants, it begins to emit a wind of its own, a stream of high-energy particles. This wind would push against the solar wind, creating a shock wave in the heliosphere. The environment of our solar system is changing chemically, magnetically, gravitationally. We are entering a new epoch. We are no longer the solar system. We are a binary system in the making, a chaotic dance between a dying star and a hungry ghost. And Earth? Earth is still just a speck, holding its breath, waiting for the gravity to reach the inner sanctum. We have watched the outer guards fall. Neptune, Uranus, Saturn, Jupiter. The Titans have been humbled. The debris is flying. The sun is waking up, and the black hole, growing brighter and larger in our sky, is closing the distance. It is crossing the asteroid belt. It is knocking on the door of Mars. The journey is far from over. In fact, the most intimate part of the dance is just beginning. What happens when the singularity gets close enough to pull on the oceans? What happens when it gets close enough to pull on time? Einstein taught us that gravity is not just a force that moves matter. It is a curve that bends time. The closer you get to a massive object, the slower time flows. As the black hole enters our immediate neighborhood, we are not just moving through space. We are moving into a different rate of existence. The clocks on Earth and the clocks in deep space would begin to disagree. We are drifting toward a horizon where the seconds stretch into hours, where the future becomes heavy, where the light itself gets tired of climbing out of the well. So, lie still. Let the gravity of the earth hold you. It is a gentle gravity, a kind gravity. It keeps the air in your room, the blanket on your bed, the blood in your veins. Cherish it, because in our story, a new gravity is coming, one that does not care about comfort, one that demands total surrender. As we end this chapter, the black hole is looming large, a second sun made of darkness and fire, casting shadows that shouldn't exist. The outer worlds are in ruin. The inner worlds are next. Welcome back to the quiet observatory of the mind. If you are just drifting in, we are deep within a story of cosmic transformation. We have watched the outer ramparts of our solar system crumble. The frozen sentinels of the Oort cloud have fled, and the gas giants, Jupiter, Saturn, Uranus, Neptune, have bowed before a new master. A rogue black hole, an invisible nomad from the depths of the Milky Way, has entered our home. It has crossed the threshold of the asteroid belt and is now approaching the most fragile, precious region of all, the inner sanctum. This is the realm of the rocky worlds. Mercury, scorched and silent. Venus, shrouded in thick, choking clouds. Mars, the rusted desert. And Earth, the blue oasis. Tonight, we witness the moment when the darkness enters the Goldilocks zone, that narrow, miraculous strip of space where it is not too hot, not too cold, but just right for life. Or at least, it was. For billions of years, life on Earth has been governed by a simple, rhythmic binary, light and dark, day and night. The sun rises, painting the world in color, and the sun sets, unveiling the mystery of the stars. Our biology is hardwired to this cycle. The circadian rhythms in your cells, the opening of flowers, the migration of birds, it is all a dance set to the tempo of the Earth's rotation relative to the sun. But as the black hole crosses the orbit of Mars, that rhythm is shattered. We would no longer have a single source of light. We would have two. The sun, our ancient parent, would still be there, burning yellow and familiar. But now, rising in the opposite sky, or perhaps chasing the sun across the dome, would be the black sun, the accretion disk of the intruder. By now, the disk has grown immense. It is fed by the gas stripped from Jupiter and the pulverized remains of asteroids. It is no longer a point of light. It is a feature, a dominant shape in the heavens. It would look like a terrifying, beautiful eye. The center is absolute void, the event horizon, a sphere of shadow about 10 or 20 miles wide, where gravity is so strong that not even light can escape. But surrounding it is a whirlpool of plasma spinning at nearly the speed of light. Friction heats this material to millions of degrees, making it shine with a brilliance that rivals, and perhaps eventually outshines, the sun itself. From the surface of Earth, the visual would be mind-bending. Because the disk is spinning so fast, the light on one side, the side spinning toward us, would be boosted by the Doppler effect, appearing brighter and bluer. The side spinning away would be dimmer and redder. It would look like a crescent of blue fire fading into a blood-red mist, wrapped around a hole in reality. And because the gravity of the black hole is so intense, it would bend the light coming from behind the disk, creating a halo that allows us to see the back of the disk simultaneously with the front. It is a geometry that defies human intuition, a shape that Escher might have dreamed of, hanging silently over our cities and oceans. With this new light in the sky, night would vanish. If the black hole is on the opposite side of Earth from the sun, we would experience a perpetual day. One side of the planet bathed in golden solar light, the other bathed in the harsh blue-white glare of the accretion disk. Imagine the confusion of the natural world. Birds would sing at 3 a.m. Nocturnal animals would stay hidden in their burrows, starving, waiting for a darkness that never comes. The forests would not sleep. The plankton in the oceans would not rise and fall. We humans, with our clocks and calendars, would try to maintain order, but the psychological weight of the endless day would be heavy. We need the dark. We need the rest. But the sky is now an open eye that never blinks. As the intruder passes Mars, we would see the fate of the red planet. Mars is small, only about half the size of Earth. It has no magnetic field to protect it. As the accretion disk's radiation sweeps over it, the thin Martian atmosphere would be stripped away violently. We might see Mars not as a steady red dot, but as a comet-like object, trailing a tail of dust and gas as it is buffeted by the winds of the black hole. Its orbit, too, would be warped. Mars might be pulled inward, crossing Earth's path, or flung outward into the freezing void. The neighbor we have dreamed of visiting for centuries is now a leaf caught in a gale, tumbling beyond our reach. And then the gravity reaches us, not the destruction yet, but the touch. The first thing we would feel is the tides. The moon has always been the mistress of our oceans, pulling the water into high and low tides as it circles us. The sun helps too, but its pull is weaker. The black hole, however, is a gravitational titan. As it draws closer to the inner system, its tidal force would begin to rival the moon's. We would see king tides that defy the charts. High tide would not just lap at the seawall, it would surge over it. Low tide would drain harbors dry, revealing shipwrecks and seabeds that haven't seen the sun in millennia. The water would seem confused, sloshing not just with the lunar rhythm, but with a new, deeper pulse, a chaotic interference pattern. In some places the tides might cancel out, leaving the water eerily still. In others, they might combine, creating walls of water that travel silently across the Atlantic and Pacific, reshaping coastlines in a single afternoon. And it wouldn't just be the water. The Earth itself is elastic. The crust floats on a mantle of molten rock. As the gravitational gradients steepen, the solid ground would begin to stretch and relax, stretch and relax. Seismographs all over the world would light up, not with the sharp jolt of tectonic plates slipping, but with a low, continuous hum, the song of the earth groaning under the strain. Dormant volcanoes, their magma chambers squeezed by the tidal forces, might wake up. We would see plumes of ash rising in Iceland, in Indonesia, in the Cascades, adding a gray veil to our already strange, bright sky. It is a reminder that a planet is not a solid rock. It is a droplet of liquid and crust held together by its own gravity. And now that hold is being challenged. Yet, amidst this physical upheaval, there is a strange, contemplative beauty. We are seeing the universe as it truly is, a play of forces. We are seeing relativity in action. The light from the black hole is not just light, it is history. The photons hitting our retinas traveled from the shredded remains of gas giants, spiraled through the warped space-time of the ergosphere, and escaped just moments before crossing the event horizon. We are watching the edge of existence. Neil deGrasse Tyson once said, "The universe is under no obligation to make sense to you." And in this moment, looking up at the two suns, that truth would settle deep in our bones. The sky does not care about our fear. It only cares about mass, energy, and momentum. As the black hole closes the distance to the 93 million miles that separate Earth from the sun, a terrifying geometry begins to form. We are entering a three-body problem. Earth is no longer just orbiting the sun. It is caught between the sun and the black hole. These two giants are now competing for custody of our little blue marble. The sun pulls us one way, the black hole pulls us another. This tug-of-war would start to circularize and then elongate our orbit. We might find ourselves pulled closer to the sun for a few months, baking in intense heat, before being swung out wide toward the cold darkness of the black hole. The seasons would lose their meaning. Winter and summer would no longer be defined by the tilt of our axis, but by our erratic distance from the heat sources. We might have a week of scorching summer, followed by a sudden, deep freeze. The climate systems, delicate and complex, would collapse into chaos. Hurricanes would form not from seasonal warmth, but from the sheer energy injection of the accretion disk's radiation. And yet, through it all, the Earth spins. That ancient angular momentum we talked about in previous stories, the spin that has lasted 4.5 billion years, keeps us turning. It acts as a gyroscope, trying to keep us stable, even as our path through space becomes a drunken wobble. Let's look inward, toward the center of the system. Mercury and Venus are the canaries in the coal mine. Mercury, the closest to the Sun, would be the first to fall. Its orbit is already eccentric, fast, and nervous. The black hole would destabilize it effortlessly. We might see Mercury simply swallowed, not by the black hole, but by the Sun. Pushed by the gravitational perturbation, it could spiral inward, vanishing into the solar atmosphere with a silent splash of plasma. Or it could be ejected, shot out past Earth like a cannonball, a gray, cratered warning shot across our bow. Venus, the hellish twin of Earth, wrapped in thick clouds of sulfuric acid and carbon dioxide, would face a different fate. Its thick atmosphere would glow under the intense X-rays from the accretion disk. The greenhouse effect, already run away, would go into overdrive. The planet would become so hot it might begin to glow in the visible spectrum, a dull red ember hanging in the sky. It is a grim preview of what could happen to atmospheres under such stress. But Venus teaches us something about resilience. It has survived collisions and resurfacing events before. It is a rock. It will endure, even if its location changes. Back on Earth, the psychological shift would be complete. We would no longer look at the sky with hope or simple curiosity. We would look at it with awe, the old definition of awe, which includes terror. We are realizing that we are not the main characters of this story. The main characters are the singularity and the star. We are the grass being trampled by elephants. And yet, this realization brings a kind of clarity. All the petty conflicts, the borders, the arguments over resources, they would seem absurdly small under the light of the black sun. Humanity might, for the first time, truly see itself as one species huddled together on a fragile raft, drifting through a storm that is bigger than any god we ever imagined. As Chapter 3 draws to a close, the black hole is now effectively inside the habitable zone. It is passing Earth's orbit, perhaps not hitting us directly yet, but crossing the line. We are now behind it, or beside it. The view changes again. We look into the heart of the darkness. We see the distortion of the stars on the other side. We see the universe magnified and twisted. And we begin to feel the change in time. The gravity is strong enough now that time dilation is no longer theoretical. The clocks on satellites are drifting wildly. The GPS systems fail. We are becoming disconnected from the precise, mechanical time we built our civilization on. We are returning to a more primal time, the time of the heartbeat, the time of the breath, the time of survival. The air is still breathable. The gravity is still holding us down, but the temperature is rising, the oceans are restless, and the sky's a masterpiece of violence. We have survived the entry, we have survived the breaking of the day, but the journey is getting deeper. We are moving from the disruption of light to the disruption of matter itself. Take a slow breath. Inhale the safety of your room. Feel the stillness of the floor beneath you. It is a gift, a temporary, beautiful gift. In our story, that floor is starting to tremble. In our story, the great tides are rising. But here, you are safe. You are just a traveler in the mind. Let the image of the blue and red accretion disk fade for a moment. Let the black sun set in your imagination. Rest in the gray quiet between the chapters. The next leg of our journey will take us into the water, into the atmosphere, into the physical shaking of the world. We have watched the sky change. Now we will watch the earth change. The oceans are waking up, and they have a story to tell. Welcome back to the silence of the drift. If you are just joining us, settle in. Let the weight of the day fall from your shoulders like a heavy coat. We are deep within a journey that is both terrifying and beautiful. A thought experiment that asks us to let go of the ground beneath our feet. We have watched the rogue black hole enter our solar system, scatter the comets of the Oort cloud, and unravel the orbits of the gas giants. We have seen it cross the asteroid belt and enter the inner sanctum, creating a second darker sun in our sky. Now, the invisible hand of gravity is reaching down to touch the surface of our world. It is no longer just a light in the sky. It is a force in the air. Tonight, we drift into the atmosphere. We explore what happens when the delicate blanket of gas that protects us begins to fray, and when the oceans, those ancient cradles of life, wake up to a new and powerful moon. Have you ever stopped to think about how thin the line is between us and the void? The atmosphere of Earth, the only place in the known universe where we can breathe, is incredibly fragile. If you wrapped a standard desktop globe in plastic wrap, that thin layer of plastic would be thicker, relatively speaking, than the air that surrounds our planet. It is a whisper of nitrogen and oxygen held to the surface by the gentle gravity of Earth. For billions of years, it has been enough. It shields us from solar radiation. It burns up meteors, and it holds the heat of the sun just close enough to keep us warm. But the atmosphere is a fluid. It flows, it reacts, and like the ocean, it has tides. As the black hole draws nearer, occupying a space that rivals the sun in gravitational influence, the air itself begins to swell. This is called an atmospheric tide, but on a scale we have never witnessed. Usually the sun heats the day side of Earth, causing the air to expand slightly, and the moon pulls on it gently. But the accretion disk of the black hole is pouring out X-rays and ultraviolet light at intensities that make the sun look like a candle. As this radiation hits the upper layers of our atmosphere, the thermosphere and the exosphere, the gas molecules become excited. They vibrate. They heat up. In physics, heat is motion. The hotter a gas becomes, the faster its particles move. If they move fast enough, they can reach escape velocity, the speed needed to break free from Earth's gravity and fly off into space. NASA's MAVEN mission observed this happening on Mars. Billions of years ago, Mars had a thick atmosphere and liquid water. But as its magnetic field died and the solar wind stripped away the gas, the planet suffocated. It became the red desert we know today. In our story, this process is happening to Earth, but accelerated. The intense heat from the black hole causes our atmosphere to puff up. The envelope of air expands outward, reaching hundreds of miles further into space than before. Satellites in low Earth orbit, like the International Space Station or the Starlink constellations, would suddenly find themselves flying through thicker air. The drag would be immense. We would see a rain of shooting stars, not from rocks, but from our own technology burning up as it spirals downward, unable to maintain speed in the expanding sky. But down here, on the surface, the sensation would be different. It would be the sound, the wind, with two heat sources, the sun on one side and the accretion disk on the other. The temperature gradients on Earth would be extreme. Wind is generated by the difference between hot and cold air. Nature hates a vacuum and it hates a difference. It always tries to equalize. So, air rushes from high pressure to low pressure, with the black sun heating the night. The global circulation patterns, the Hadley cells and the jet stream would break down. They would be replaced by super-rotation winds, vast rivers of air moving at hundreds of miles per hour, trying desperately to balance the temperature of a planet that is baking on all sides. These wouldn't just be storms. They would be hypercanes. A hypercane is a theoretical type of hurricane that could form if ocean temperatures reached around 50 degrees Celsius, 122 degrees Fahrenheit. With the extra heat from the black hole, the tropical oceans could easily reach this boiling point. These storms would be the size of continents. They would reach up into the stratosphere, towering monsters of cloud and lightning that would never dissipate because the fuel, the hot water, never cools down. From space, Earth would look less like a blue marble and more like a churning ball of white cotton, the surface hidden beneath a permanent, violent overcast. And yet, inside the chaos, there is a rhythm. The sound of the wind is just the sound of the planet breathing, faster and harder than it ever has before. It is the sound of a system trying to survive. Let's drift down from the clouds to the water. The oceans are the heaviest things on the surface of Earth. Water is dense, and it responds instantly to gravity. We talked about the tides in the last chapter, but now, let's visualize them. As the black hole approaches, its gravity pulls the Earth into an oblong shape, like a rugby ball. The solid rock stretches a few meters, but the water stacks up. The bulge of water that faces the black hole would become a moving mountain of the sea, kilometers high. This isn't a wave that breaks on the shore. It is the ocean itself lifting up. If you were standing on a coastline, looking out at the horizon, you wouldn't see a wall of water coming at you. You would simply see the sea level rising, relentlessly. It would swallow the beach, then the dunes, then the roads, then the cities. It would be a silent, hydraulic invasion. The water would flow inland for hundreds of miles, creating temporary inland seas, before receding just as fast when the Earth rotates away from the black hole's pull. The map of the world would change every 6 hours. Islands would disappear and reappear. Peninsulas would become islands. The geography we memorized in school would be erased and redrawn twice a day by the hand of gravity. This deep mixing of the oceans would have a strange side effect. The cold, nutrient-rich water from the abyss would be churned up to the surface. For a brief moment, the biological productivity of the ocean might explode. Blooms of algae, fed by the sudden upwelling of nutrients and the intense light of the accretion disk, might turn the seas vibrant green or red. Even as the world ends, life tries to bloom. It is a stubborn, beautiful thing. It refuses to give up until the very last drop of water is gone. And that is the danger, because as the atmosphere heats up and the winds strip away the upper layers, the pressure drops. Water needs atmospheric pressure to stay liquid. If the air gets too thin, the oceans will begin to boil, not from heat, but from the vacuum. We are not there yet, but the humidity would be suffocating. The air would be thick, heavy, and hot. It would feel like a sauna that never ends. And through the haze, the light would be eerie. The scattering of light in the atmosphere, Rayleigh scattering, which gives us our blue sky, would be distorted by the dust and salt spray whipped up by the hypercanes. The sky might turn a bruised purple or a sickly yellow gray. The familiar blue, that symbol of safety and calm, would fade into memory. We would be living on a twilight world, caught between the furnace of the accretion disk and the memory of the sun. And yet, amid this tumult, I want you to find a center of calm. Close your eyes for a moment. Listen to the sound of your own breathing, in and out. That air you are breathing is a legacy. It was made by ancient bacteria, filtered by vast forests, and cycled through the oceans for eons. It is a gift of history. In our story, that gift is being reclaimed by the cosmos. But right now, in your reality, it is still yours. It is cool and fresh. It fills your lungs with life. The atmosphere of Earth is still holding you. The gravity is still gentle. The storm is only in our minds. There is a concept in astrophysics called the Roche limit. It is the distance at which a celestial body, held together only by its own gravity, will disintegrate due to a second celestial body's tidal forces exceeding the first body's gravitational self-attraction. In simpler terms, it is the line where a planet gets ripped apart. We are drifting toward that line. The black hole is getting closer. The tides are not just moving water anymore. They are stressing the tectonic plates to their breaking point. The hum of the earth we mentioned earlier is becoming a roar. The ground is vibrating constantly, a planetary shivering. Deep beneath the crust, the magma is responding too. The earth is not just a rock, it is a battery of heat. As the tidal forces squeeze and stretch the planet, that friction generates internal heat, tidal heating. It is the same process that keeps Jupiter's moon Io volcanic and alive. Io is the most volcanically active body in the solar system because Jupiter squeezes it like a stress ball. Now, Earth is the stress ball. The volcanoes that woke up in the last chapter are now joined by fissures opening in the ground, cracks in the crust, where the liquid fire of the mantle bleeds through. We are seeing the return of the Hadean Eon, the hellish early days of Earth's formation. We are witnessing the de-evolution of our home, from a blue marble teeming with technology and life, back to a chaotic world of storms and volcanoes, and perhaps, eventually, back to dust. It is a humbling trajectory. It reminds us that stability is a phase, not a permanent state. We are guests here. The landlord is physics, and the lease is renewable only as long as the conditions allow. But there is beauty in the breakdown. The aurora borealis, now permanent and global, would dance over the hypercanes. The lightning from the storms would illuminate the rising steam of the boiling oceans. It would be a canvas of absolute energy. As the black hole continues its relentless approach, passing the orbit of the moon itself would face a crisis. It is smaller than Earth, less held together by gravity. Before the Earth breaks, the moon might shatter. Imagine looking up and seeing our faithful companion, the white face in the night sky, begin to crack, to see it stretch into a stream of glowing debris, a ring of white dust forming around the Earth, mimicking the rings of Saturn. We would have a ring system for the last few days of our existence, a funeral wreath made of moonlight. The atmosphere is thinning. The breathing of the world is becoming shallow. The winds are screaming, but there is less air to carry the sound. We are approaching the moment of the great lift, the moment when the gravity of the black hole finally overpowers the gravity of Earth, not just for the air, but for the rocks, the buildings, and us. We are preparing to leave the surface, not in spaceships, but in the grip of the tide. As we end this chapter, let us hold on to the image of the ringed earth, battered by storms, glowing with auroras, drifting into the dark. It is a tragic image, yes, but it is also a testament to the forces that shaped us. We are made of star stuff, as Carl Sagan said, and to the stars we are returning, even if it is through the throat of a monster. The silence of space is waiting to swallow the noise of our atmosphere. The vacuum is patient. Have you ever had a flying dream, the kind where you push off the ground and simply don't come back down? For a moment, it feels impossible, a violation of the oldest rule we know. What goes up must come down. Gravity is the author of that rule. It is the invisible chain that binds us to the floor, to the chair, to the bed. It gives us weight, which is really just a measurement of how hard the earth is pulling on us. We spend our whole lives fighting it, standing up, lifting heavy things, building skyscrapers that defy the downward pull. But in our story, the fight is over. We have reached the moment of the great unbinding. The rogue black hole, now a colossal presence filling half the sky, has brought us to a mathematical boundary known as the Roche limit. This is the invisible line in the sand, where the tidal forces of a massive object become stronger than the gravity holding a smaller object together. When a planet crosses this line, it doesn't just crash, it dissolves, it surrenders. Tonight, we drift into that surrender. We imagine what it feels like when the ground beneath our feet stops being a floor and becomes a cloud. We imagine the moment when the earth, our ancient vessel, finally lets go. To understand what is happening, we have to look at the geometry of the pull. Gravity weakens with distance. It is an inverse square law. This means that the side of the earth facing the black hole is being pulled much, much harder than the side facing away. Until now, the Earth's own internal gravity, the force that pulls everything toward the core, was strong enough to keep the planet in a spherical shape. We were a ball of rock, magma, and water, held together by our own mass. But the black hole is a gravitational bully. As we cross the Roche limit, the difference in pull between the near side and the far side of Earth becomes greater than the pull of Earth's core. The result is a force that stretches the planet apart. It is no longer a tug of war, it is a demolition. The spherical Earth begins to elongate, stretching into the shape of an American football. And then, a cigar. Imagine standing in a city as this happens. The first sensation wouldn't be pain, it would be lightness. As the black hole's gravity counteracts the Earth's gravity, you would feel as if you were in a rapidly descending elevator. The numbers on the scale would drop. 150 pounds becomes 100, then 50, then 0. We would enter a state of free fall, even while standing on the sidewalk. But the sidewalk itself wouldn't stay still. The crust of the Earth, that thin shell of cold rock we live on, is brittle. It cannot stretch like the oceans or the atmosphere. When the planet begins to distort, the crust shatters. We are not talking about earthquakes anymore. We are talking about the fragmentation of the continents. Great fissures, hundreds of miles wide, would open up silently, exposing the glowing red blood of the planet, the mantle beneath. But unlike a normal earthquake, the debris wouldn't fall into these cracks. It would float up out of them. Boulders the size of houses, cars, trees, and pieces of buildings would gently lift off the surface, drawn upward by the insatiable hunger of the black hole. We would see whole cities detaching from their foundations, breaking apart into their constituent bricks and steel beams, and drifting into the sky. It would look like a slow-motion explosion, a rapture of matter. There is a terrifying beauty in this. The chaos of civilization, the traffic, the noise, the clutter, is being organized into a stream. Everything is moving in the same direction now. The complex structures we built are being simplified, returned to their raw elements. Dust to dust, but rising, not falling. As the earth stretches further, the core itself is breached. The iron heart of our planet, which has spun in darkness for 4 billion years, generating our magnetic field, is suddenly exposed to the vacuum. When the pressure is released, the core would expand violently, not as fire, but as liquid metal splashing into the void. It would be a fountain of gold and red against the backdrop of the black accretion disk. The magnetic field would collapse instantly. The auroras would vanish, replaced by the raw, unfiltered radiation of the cosmos. We are no longer protected. We are no longer hidden. We are open to the universe in a way we have never been. The atmosphere, what was left of it, would be the first to leave, streaming away like smoke from a blown-out candle. Sound would vanish with it. The crashing of the continents, the roaring of the magma, it would all be silenced. The end of the world would be a silent movie. And us? In this scenario, biology has long since ceased to function. But our consciousness, the watcher in this story, remains. We are floating among the ruins. We are drifting in a sea of diamonds, the crystallized carbon from the deep mantle, and shards of granite. We are part of a vast river of debris that is spiraling inward. This river has a name, an accretion stream. The Earth is no longer a planet. It is a streak of paint on the canvas of the black hole. We are joining the rings. We are becoming the light that we feared in the earlier chapters. The matter that was once libraries, forests, and oceans is now friction-heated plasma, adding its tiny spark to the brilliance of the disk. There is a profound philosophical shift here. We spend our lives defining ourselves by our separation. I am here, you are there. This is my house, that is yours. This is the earth, that is space. But the Roche limit erases these boundaries. There is no earth anymore. There is only the stream. We are returning to a state of unity. We are becoming star stuff again, quite literally. The atoms in your body were forged in the hearts of dying stars billions of years ago. They clumped together for a brief moment to form a human, to form a planet. And now, gravity is harvesting them, gathering them back to be recycled into energy. It is not death. It is a change of state. It is the closing of a cycle that began before the sun was born. As we look back, if back even exists in this tumbling geometry, we might see the moon, or rather, the debris field that used to be the moon. It crossed the Roche limit before we did. It is now a glittering arc of white dust leading the way. We are following our companion into the dark. Mars is somewhere behind us, perhaps still intact, watching the destruction of its blue neighbor. Jupiter and Saturn are already part of the outer disk, their gases painting sweeping strokes of orange and yellow in the accretion flow. The solar system is being essentially pureed, blended into a disk of uniform light. The individuality of the planets is gone. Only the gravity remains. This feeling of weightlessness, of floating, is strangely peaceful. The anxiety of falling comes from the fear of hitting the ground. But when there is no ground, there is no impact. There is only the float. We are suspended in the great void, carried by currents of space-time that are older than time itself. The down we feared is just the direction of the singularity, and we are flowing toward it like water in a riverbed. It is effortless. Nature does not struggle. It flows, and now we flow with it. Let's pause and feel the safety of your reality again. Wiggle your toes. Feel the sheets or the floor. That pressure you feel, that is the earth hugging you. That is the roach limit not being crossed. It is a miracle, really. The fact that our planet stays round, that our atmosphere stays put, that the ground stays solid. It is a balancing act that has held for eons. We take it for granted every second. But tonight, having seen the alternative, having imagined the great unbinding, perhaps we can respect that stability a little more. The floor is not just a surface. It is a promise that for now we are held. We are home. But in the story, the journey is not over. We have dissolved the planet, yes, but we have not yet reached the center. We are currently in the accretion disk, spinning at wild speeds, glowing with heat, stripping down to our atoms. But ahead of us lies the event horizon, the point of no return, the black sphere that sits at the center of the chaos. It is the most mysterious object in science. It is the door that locks from the inside. What happens when our stream of matter crosses that threshold? What does the universe look like from the edge of the abyss? Einstein's theories tell us that strange things happen at the edge. Time stops, space twists, light freezes. We are about to enter the realm of the impossible. We are about to ask the question, what is on the other side of the bottom? Is it a wall? Is it a tunnel? Or is it simply the end of the story? The debris field is accelerating. The friction is building. The light is blinding. But the center is dark, a circle of absolute silence waiting to catch us. As we end Chapter 5, we are no longer earthlings. We are dust. We are light. We are momentum. We have surrendered our form to the gravity of the wanderer, and in that surrender, we have found a strange kind of freedom. No more bills, no more borders, no more clocks. Just the spin, just the light, just the long, beautiful fall into the mystery. Take a slow breath. Inhale the stillness. Exhale the chaos. You are the observer, safe in the theater of your mind. The screen is bright, but the room is dark and cool. Rest here for a moment. Gather your strength, because the next chapter is going to take us closer to the edge than any human has ever gone. We are going to look into the mirror of the black hole and see if we can find our reflection. Welcome back to the stillness. If you are just finding your way here, we are in the middle of a transformation. We have left the solid ground of Earth behind. We have crossed the roach limit, and the matter that once made up our planet, our homes, and our bodies has been unspooled into a stream of glittering debris, spiraling inward through the accretion disk. We are no longer bound by biology or geology. We are pure momentum, riding the curvature of space-time toward the center of the mystery. Ahead of us lies the most absolute boundary in the universe, the event horizon. In physics, an event is a point in space and time. A horizon is the limit of what can be seen. So, the event horizon is literally the edge of reality as we know it. It is the point where the escape velocity equals the speed of light. To cross it is to leave the observable universe forever. Tonight, we drift toward that edge. We explore the paradox of time at the brink of the abyss, and we ask the question, does falling into a black hole mean you are destroyed? Or does it mean you become eternal? As we spiral closer, the black hole dominates the view. It is no longer an eye. It is the sky. It is a sphere of absolute nothingness, so black that it doesn't look like a color. It looks like a cut in the fabric of vision. But around this darkness, the universe is putting on its final, frantic performance. We are moving at relativistic speeds now, significant fractions of the speed of light. At these speeds, the view of the universe changes. The stars behind us aren't just receding, they are gathering, due to an effect called relativistic aberration, or beaming. The light from the entire sky is being squeezed into a bright tunnel ahead of us. It is as if the cosmos is shrinking into a spotlight, guiding us down. But the most profound change is not in space, it is in time. Einstein taught us that gravity drags on time just as it drags on matter. The deeper you go into a gravitational well, the slower time ticks relative to the outside world. This is not an illusion, it is physical law. As we approach the horizon, we are entering a region of extreme time dilation. If we could look back at the universe, we are leaving, at the distant stars, at the other galaxies, we would see them accelerating. The evolution of the cosmos would seem to be on fast forward. Stars would be born, live their billions of years, and burn out in what feels like minutes to us. Galaxies would rotate like spinning coins. We are becoming time travelers, sinking into the future of the universe simply by falling toward a place where time stands still. Now, consider the perspective of someone watching us. Imagine a distant observer, safe in a spaceship far away, watching the debris of Earth fall in. What would they see? You might think they would see us vanish instantly into the black, but they wouldn't. As we get closer to the horizon, the light reflecting off us has to climb out of the gravity well to reach them. This climb takes energy. As light loses energy, its frequency drops. It shifts toward the red end of the spectrum. This is called gravitational redshift. To the watcher, our movements would begin to slow down. The movie of our fall would decelerate. We would look like we were moving through molasses, then through amber, then through glass. As we touched the very edge of the horizon, the watcher would see us stop. We would freeze. The light from our final moment would be stretched and dimmed, turning deep red, then infrared, then radio waves, fading slowly into absolute silence. But we would never disappear. To the outside universe, nothing ever truly falls into a black hole. It just piles up on the surface, a ghostly layer of frozen memories plastered against the event horizon. In the early days of relativity, before the term black hole was coined, physicists called these objects frozen stars. It is a beautiful name. It suggests that the black hole is a museum of everything it has ever consumed, preserving the image of its history on its skin, held in an eternal static now. But that is the view from the outside. For us, the ones falling, there is no freezing. There is no pause. We look at our watches, and the second hand ticks normally. We look at our hands, and they move at normal speed. We are falling freely. The horizon is not a solid wall we crash into. It is a mathematical shadow. We could cross it without even knowing, except for the geometry. And what a geometry it is. Just before we cross, we pass through a region called the photon sphere. This is a specific distance, 1.5 times the Schwarzschild radius, where gravity is so strong that photons, particles of light, are forced to orbit the black hole. Imagine orbiting in a place where light travels in circles. If you looked to the side, you wouldn't see the black hole or the stars. You would see the back of your own head. You would see the image of yourself from a moment ago, having circled the black hole and returned to your eyes. And behind that image, another image of yourself from an earlier orbit, and another, an infinite tunnel of reflections nested like Russian dolls. But it's not just you. The photon sphere captures light from the entire history of the black hole. It is a ring of trapped light that contains the images of everything that has ever fallen in. As we pass through this layer, we are passing through the visual archive of the abyss. For a split second, we might see the ghosts of ancient stars, the dust of devoured planets, all swirling in a thin, glowing shell of trapped history. It is a library of light, a place where the past is caught in a loop, unable to leave, unable to fall, just turning forever in the dark. It is the most lonely and beautiful place in the cosmos. And then we drop below it. We leave the trapped light behind. The sky above us, the circle of the universe, begins to shrink. The darkness below us expands. We are approaching the point of no return. There is a deep peace in this inevitability. In life, we are paralyzed by choices. We worry about turning left or right, about choosing the wrong path, about the what-ifs. But here, there are no choices. All paths lead inward. In general relativity, once you cross the horizon, the direction inward toward the singularity becomes the same as the direction forward in time. You can no more avoid hitting the center than you can avoid next Tuesday. Space and time have swapped roles. The radial distance to the center becomes a time coordinate, a countdown, and the future becomes a physical location. This sounds terrifying, but think of it as a release. The struggle against the current is over. We have let go of the riverbank, and the river is taking us exactly where we need to go. The noise of the accretion disk, the heat, the radiation, all of that is outside. As we slip through the horizon, we might expect a crash, a siren, a flash. But the math suggests silence. It is a threshold without a door. One moment, you are in a universe where you can send a signal to Earth. The next moment, you are in a universe where no signal can ever leave. You are isolated in a bubble of privacy so absolute that not even the laws of physics can intrude. The light from the universe outside can still follow us in. We can see the stars, the galaxies, the debris of our former home falling with us. But nothing from inside can ever look back. We are in a one-way mirror. We are the secret keepers of the cosmos. Everything we see, everything we experience from this point on, belongs only to us. It is the ultimate intimacy. In a universe of constant sharing, of data, of noise, the interior of a black hole is the only place where secrets are kept forever. As the horizon rises above us, closing the door to the outside, the darkness is not empty. It is heavy with potential. We are falling toward the singularity, the point where density becomes infinite and space becomes zero. But we are not there yet. We are in the interior, a vast warped region of space-time that shouldn't exist, yet does. Here, the tidal forces, the spaghettification, would begin to intensify. The difference in gravity between your head and your feet would become extreme. But in our story, we are already dust. We are already a stream. So we don't feel the pain of stretching. We feel the elongation of being. We are being drawn out into long, thin threads of matter, aligning with the geometry of the fall. We are becoming part of the black hole's mass. We are adding to its gravity. In a strange way, by falling in, we are making it stronger. We are making it larger. The horizon expands slightly as it swallows us. We are not lost. We are assimilated. The gravity that we added to the whole will now pull on other stars, other worlds. For trillions of years, we have become the ghost in the machine. We are the force that shapes the galaxy from the shadows. Let's pause the fall for a moment. Let's float here, just inside the skin of the monster. The universe outside is a bright circle shrinking overhead. The dark is all around. It is quiet, the kind of quiet you find in a deep cave or at the bottom of the ocean, but deeper. It is the silence of the end of time. Back in your room, the clock is ticking. The world is moving forward. Cars are driving. People are talking. The earth is spinning. It is all so busy. It is all so fast. But here, in the thought experiment, we have found a place where fast doesn't matter anymore. We have found the frozen moment. Take a deep breath. Feel the continuity of your own existence. You are here. You are now. You are not frozen. But you can carry a piece of this stillness with you. You can remember that beneath the noise of daily life, there is a deep, silent substrate to the universe, a place where things just are. The black hole is often seen as a destroyer, but tonight, let's see it as a vault, a cosmic safe deposit box. It takes things, light, matter, information, and it keeps them. It locks them away from the decay and entropy of the outside world. In a universe where everything fades, where stars burn out and mountains crumble, the black hole is the only thing that endures. It is the most permanent object in existence. By falling in, the solar system has joined that permanence. We are no longer fleeting. We are etched into the geometry of space-time forever. As Chapter 6 closes, we are fully inside. The door is shut. The universe we knew is a memory. Ahead of us lies the singularity, the mystery at the center, the place where the math breaks, the place where God divided by zero. What happens when we hit the bottom? Does the story end? Or does the bottom open up into something else? Some theories suggest that the bottom is not a dead end, but a bridge, a wormhole, a white hole opening in another universe, a big bang on the other side. Could our end be someone else's beginning? Could the death of our solar system be the seed of a new galaxy? We will drift toward that possibility next. We will journey to the center of the center. We will confront the singularity. But for now, rest in the quiet of the interior. You are safe in the dark. You are held by the strongest force in nature. Drift, sleep. The journey continues downward. Welcome back to the deep. If you are still with me, we are drifting in a place that no human eyes have ever seen and no human voice has ever described, except in the language of mathematics. We have left the universe behind. The stars, the galaxies, the familiar constellations. They are all on the other side of the door now. We have crossed the event horizon, the point of no return. We are falling through the dark interior of a supermassive black hole, a region where the rules of reality are rewritten. Up and down have lost their meaning. There is only inward, and inward is not a direction in space anymore. It is a direction in time. We are falling toward tomorrow, and tomorrow is a single point. Tonight, we drift toward the most mysterious concept in all of physics. We drift toward the singularity, the heart of the black hole, the place where the story of matter ends and the story of mystery begins. In the previous chapter, we talked about how space and time swap roles inside the horizon. It is a strange thought, but let's sit with it for a moment. In your room right now, you have freedom in space. You can walk left, right, forward, backward. But you have no freedom in time. You are forced to move forward, second by second, toward the future. You cannot stop the clock. You cannot go back to yesterday. Inside a black hole, this inevitable forward march applies to space. You are forced to move toward the center. Resisting the singularity is as impossible as resisting next Monday. It is not just a destination. It is your future. And just like you can't see next week until it arrives, you can't see the singularity until you hit it. It lies ahead of us in the dark. A moment of destiny waiting to happen. As we fall deeper, the tidal forces, the spaghettification we touched on, shift from the macroscopic to the microscopic. We have already seen planets torn apart, moons crumbled into dust, and rocks stretched into streams. But now, the gravity becomes so intense that it begins to pull on the atoms themselves. An atom is mostly empty space, a tiny nucleus of protons and neutrons surrounded by a cloud of electrons. The gravity of the singularity is now changing so rapidly over such short distances that it pulls the electrons away from the nucleus. The electromagnetic force, the glue that holds chemistry together, is overpowered. The atoms of what was once earth, what was once water, what was once us, are stripped bare. We are no longer matter as we know it. We are a plasma of fundamental particles, a soup of electricity and mass flowing in the dark. It sounds violent, but in the silence of the vacuum, it is simply a dismantling, a return to simplicity. Complexity is being erased. The information of how the earth looked, the shape of the continents, the words in our books, it is all being scrambled into entropy. But physics tells us that information might not be destroyed, only hidden. Perhaps we are not being erased. We are being encoded, written into the holographic fabric of space-time itself. Ahead of us, the singularity awaits. What is it? According to Einstein's general relativity, if you follow the curvature of space all the way to the bottom, you eventually reach a point where the mass is compressed into zero volume. Imagine taking the Earth, crushing it to the size of a marble, then a grain of sand, then an atom, and then smaller. Keep going until there is no size left at all. Yet, the mass is still there. Mass divided by zero volume equals infinite density. This is the singularity. It is a flaw in the math, a place where the equations produce infinity and stop making sense. It is a signpost that says, here, the known laws of physics break down. As we approach this point, we are entering the realm of quantum gravity. This is the holy grail of physics, the missing link that unites the smooth curves of relativity with the jagged jitter of quantum mechanics. At the singularity, gravity is so strong that it acts on the quantum scale. Space is no longer a smooth sheet. It is a foam, a churning, boiling froth of geometry, where cause and effect might detach, where time might loop or shatter. Some physicists, like Roger Penrose and Stephen Hawking, spent their lives trying to peek behind this curtain. They suggested that the singularity is not just a point, but a boundary, the end of time itself. Imagine reaching the end of a book, the last period on the last page. That is what the singularity represents for the solar system. It is the final full stop. But what does it feel like to approach the end of time? It must be a feeling of absolute compression. Everything that ever fell into the black hole, billions of years of starlight, gas clouds, planets, perhaps other civilizations, is being squeezed into the same infinitesimal point. We are joining a gathering of cosmic proportions. The separation between things is vanishing. In the outside world, there is distance between you and me, between the earth and the sun. Here, distance is being deleted. We are being pressed into a unity so tight that there is no other anymore. There is only one. There is a spiritual echo in this physical violence. Mystics have long talked about the oneness of the universe, the illusion of separation. The singularity is the physical realization of that idea. It is the ultimate reunion. All the matter that was scattered by the Big Bang, flung out into the cold void to form separate stars and separate worlds, is finally coming back together. We are returning to the seed. We are going home to the source. As we drift closer to this mathematical infinity, the darkness around us is not empty. It is heavy. You can feel the weight of the star that created this whole and the weight of everything it has eaten. It is a pressure that wraps around existence. And yet, because we are part of the stream, we don't feel crushed. We feel integrated. The anxiety of the self, the worry about our own small lives, evaporates because the self cannot survive here. Only the essence survives. Only the energy. And energy, as we know, cannot be created or destroyed. It can only change form. We are changing form. Let's pause the descent for a moment. Let's hover just nanoseconds before the end. In this frozen slice of time, try to imagine the scale. We are smaller than atoms now. We are threads of quantum vibration. And ahead of us is the monster. But is it a monster, or is it a womb? The Big Bang, the moment of creation, began as a singularity, a point of infinite density that exploded outward to create the universe. By falling into a black hole, are we simply seeing the reverse of the Big Bang, the Big Crunch? Some theories in cosmology suggest that every black hole contains a universe inside it, that when matter is crushed to infinite density, it bounces back out, creating a new bubble of space-time, a new cosmos expanding on the other side. This is called the Fagnocchi cosmology, or the Smolin selection theory. If this is true, then our death is not a death at all. It is a birth. The destruction of the solar system is the fuel for a new genesis. The light of our sun, the water of our oceans, the atoms of our bodies, they are the building blocks of a new reality that will unfold on the other side of the singularity. We are not falling into a grave. We are falling into a nursery. This perspective changes everything. The fear of the dark becomes the anticipation of the new. The silence becomes a held breath before the first cry of a new universe. We are the seeds. The black hole is the soil, and the gravity is the hand that plants us. But we must stay with the current reality. The bounce is theoretical. The crushing is real. As we hit the singularity, the laws of geometry imply that time simply stops. There is no after. The timeline terminates. It is like walking to the North Pole. Once you are standing on the North Pole, you cannot walk any further north. There is no north left. At the singularity, there is no tomorrow left. We have used up all our time. We have reached the edge of the map. In this final fraction of a second, the universe might reveal its deepest secret to us. The unified field theory, the master equation, the simple rule that governs everything from the spin of a quark to the rotation of a galaxy. Scientists on Earth build massive colliders miles wide, smashing particles together to try and glimpse this rule. They hunt for the Higgs boson, for dark matter, for gravitons. They are picking at the edges of the puzzle. But here, at the singularity, the puzzle is solved. The answer is staring us in the face. It is likely a single, elegant truth that everything is one thing, that gravity, electromagnetism, the nuclear forces, they are all just different faces of the same crystal. We see it now. The beauty of the design. It is perfect. It is simple. And then we touch it. The moment of contact with this singularity is the moment the script ends for the matter. The story of the atoms of the solar system is over. They have merged with the infinite. But the story of the black hole continues. It has grown slightly larger. It has gained the mass of a yellow dwarf star and a few rocky planets. It is slightly heavier, slightly wider. It sits in the galaxy, dark and silent, hiding the treasure it has just collected. Back in your room, the air is still. The ground is solid. You are miles and years away from any singularity. You are safe in the low-density universe. You are safe in the realm of open space and flowing time. But take a moment to feel the gravity that holds you to the earth. It is the same force, the same hand. It is just touching you gently here, instead of squeezing you infinitely. It is a connection. You are connected to the black holes of the universe by the very weight of your body. The singularity is a concept that challenges the human mind because we are creatures of limits. We understand starts and finishes. We understand boundaries. But infinity breaks us. Zero volume breaks us. It is the ultimate koan, the riddle that cannot be answered with words, only with experience. And the experience is one of total surrender. We have fallen from the Oort cloud, past the giants, past the earth, through the atmosphere, across the Roche limit, through the event horizon, and now into the singularity. We have completed the journey of matter. We have gone from dust to star, from star to planet, from planet to life. And now, from life, back to the infinite point. It is a full circle, a cosmic breath, in and out. But is the story truly over? We mentioned the bounce. We mentioned the other side. And we mentioned the information. If the information of our solar system is preserved on the horizon or inside the quantum foam, then perhaps there is a ghost of us that remains. A memory in the structure of space. And there is another twist. Black holes are not truly black. Stephen Hawking predicted that they emit a faint radiation. Hawking radiation. Over unimaginable eons, black holes slowly evaporate. They bleed energy back into the universe. Particle by particle, the mass they stole is returned. It takes trillions of years, googles of years, but eventually the black hole will shrink and vanish. And when it does, what happens to everything it swallowed? Is it released? Does it come back out? This is the next phase of our journey. We have reached the bottom. Now we must wait for the evaporation. We must wait for the deep time of the universe to unfold. We are going to drift through the eons, watching the black hole slowly dissolve, and see if we can find our way back to the light. The journey into the hole is fast. The journey out is slow, incredibly slow. So, let the idea of the singularity fade. Let the pressure lift. Imagine that you have passed through the eye of the needle. You are no longer compressed. You are diffused. You are part of the black hole's energy field now. You are the sleeping giant. Rest here, in the heart of the mystery. The crushing is done. The silence is absolute. You have arrived. And in this arrival, there is a strange, deep peace. The peace of having nowhere else to go. The peace of being exactly where the universe intended you to be. Welcome back to the drift. If you are just joining us, or if you have been floating with us through the singularity, we have arrived at a strange destination. We are no longer talking about seconds, minutes, or hours. We are no longer talking about years or even millennia. We have entered the realm of deep time. The solar system is gone. The earth, the sun, the planets, they have all been crushed into the infinite point at the center of the black hole. The violent part of the story is over. The screaming winds, the tearing tides, the crashing of worlds, that was just the opening act. Now, we settle in for the long, silent middle. Tonight, we explore the slow death of a black hole. We ask the question, does anything last forever? And we discover that even the monsters of the universe are mortal, leaking their lives away, one quantum drop at a time, into the cold dark. For a long time, Physicists believed that black holes were perfect traps. They thought that once something crossed the event horizon, it was gone for good, deleted from the universe, locked in a safe that had no key. The black hole would just sit there, growing bigger as it ate more, eternal and unchanging, a permanent scar on the face of space-time. But in 1974, a young physicist named Stephen Hawking changed everything. He applied quantum mechanics, the physics of the very small, to the event horizon, the geometry of the very large. And he found something shocking. He found that black holes are not truly black. They glow, faintly, coldly, invisibly, but they glow. To understand this, we have to look at empty space. In classical physics, a vacuum is empty. Nothing is there. But in quantum physics, there is no such thing as nothing. Empty space is actually a seething, boiling foam of energy. Tiny particles and antiparticles are constantly popping into existence, borrowing energy from the vacuum, snapping together, and annihilating each other in a flash of energy, returning what they borrowed. This happens everywhere, all the time. It is happening in the air in your room, inside your body, and in the deep void between galaxies. It is called quantum fluctuation. Usually, these pairs appear and disappear so fast that they don't affect anything. They are virtual particles, but at the edge of a black hole, at the sharp line of the event horizon, something different happens. Imagine a pair of these particles popping into existence right on the boundary. One is a particle of matter, the other is a particle of antimatter. In the fraction of a nanosecond before they can snap back together and vanish, gravity interferes. One of the particles falls into the black hole. The other, escaping the pull by a hair's breadth, flies off into the universe. The pair is separated. They can never annihilate. The particle that fell in is lost, but the particle that escaped becomes real. It becomes a photon of radiation. To a distant observer, it looks like the black hole has just emitted a particle. But energy cannot be created from nothing. The universe balances its books strictly. If a new particle has been created outside, the energy for it must have come from somewhere. It came from the black hole. The particle that fell in has negative energy relative to the outside universe. When it hits this singularity, it subtracts mass from the black hole. This is the mind-bending truth of Hawking radiation. By eating the negative particle, the black hole loses weight. It shrinks. It evaporates. But this process is incredibly, agonizingly slow. The temperature of this radiation depends on the mass of the black hole. A small black hole is hot and evaporates fast. But a supermassive black hole, like the one that swallowed our solar system, is incredibly cold. Its temperature is a tiny fraction of a degree above absolute zero. It emits radiation so slowly that it would take a stopwatch longer than the current age of the universe to measure a single tick of mass loss. We are talking about time scales that break the human imagination. We call this deep time. Let's try to visualize it. Imagine a mountain of diamond, 10 miles high and 10 miles wide. Once every million years, a bird flies by and brushes its wing against the peak, wearing away a single atom. By the time the mountain is worn down to nothing, the black hole will have barely started to shrink. We are talking about numbers like a Google years. That's a 1 followed by 100 zeros. It is a period so long that the entire history of life on Earth, from the first bacteria to the last human, is less than a blink of an eye. It is effectively eternity. But it is not eternity. It is a countdown. So, let's sit in the darkness and watch the universe age. While the black hole is slowly breathing out its mass, the rest of the cosmos is moving on. The era of starlight, the time we live in now, where galaxies are filled with burning stars, is just a brief phase. As we wait in the black hole's gravity, we would watch the stars go out. The massive blue stars die first, exploding in supernovas. Then the yellow suns, like ours was, swell into red giants and fade into white dwarfs. Finally, the red dwarfs, the small, miserly stars that burn for trillions of years, will exhaust their fuel. One by one, the lights in the sky will turn off. The galaxies will dim. The beautiful spiral arms of the Milky Way will dissolve as stars either fall into the central black hole or are flung out into the void. The universe will enter the degenerate era, a time of corpses. The only things left will be black holes, neutron stars, and cooling white dwarfs. The sky will be black, truly black, forever. And in that darkness, the black holes will be the kings. They will be the batteries of the dead universe, holding on to the mass they collected during the glory days of starlight. Our black hole, the tomb of the solar system, drifts through this graveyard. It is a lonely existence. There are no more planets to eat, no more gas clouds to swirl. It is just a silent sphere of gravity, slowly leaking its treasure back into the void. This brings us to a profound realization. We are still in there. The information that made up the Earth, the pattern of your DNA, the history of our civilization. It is all locked inside the horizon or plastered on its surface, depending on which theory you believe. We are the cargo in a time capsule that is outlasting the stars themselves. In a way, being swallowed by a black hole was the only way to survive the end of the universe. If Earth had remained in orbit, it would have been destroyed when the sun expanded. If the sun survived, it would have eventually faded to a cold rock. But inside the black hole, the mass is preserved. We are being held in a state of suspension, carried forward into the deepest reaches of time. We are the ultimate survivors, riding the ghost of a star into the heat death of the cosmos. But the leak continues. Drip, drip, drip. As the black hole loses mass, it gets smaller, and as it gets smaller, it gets hotter. This is the paradox of Hawking radiation. A shrinking black hole emits radiation faster, it accelerates. For billions of years, the process is invisible. But as the black hole shrinks from the size of a solar system to the size of a star, then to the size of a planet, then to the size of an atom, the evaporation turns into a boil. This is a strange comfort. Physics tells us that nothing is stagnant. Even in death, there is activity. Even in the absolute cold of the far future, there is energy moving. Nature refuses to be still. It refuses to hold on to anything forever. The black hole, the ultimate hoarder, is eventually forced to give everything back. It is a lesson in impermanence. We build our lives on the idea of keeping things, keeping our houses, keeping our youth, keeping our memories. But the universe is built on the idea of flow. Things come together and things fall apart. The black hole is just a very, very slow pause in that flow. Imagine the silence of this future epoch. There is no sound because there is no atmosphere anywhere to carry it. There is no light because the stars are gone. There is only the stretching of space-time as the universe continues to expand, driven by dark energy. The galaxies are pushing apart so fast that they are invisible to each other. Our black hole is an island in an ocean of infinite dark. And yet, it hums, a quantum hum, a vibration of particles escaping the prison. If you could hover near the horizon in this distant future, you wouldn't see the blinding accretion disk anymore. That fuel is long gone. You would see a faint, ghostly glow, the Hawking radiation. It is a light made of pure math, a light made of stolen mass. It is the solar system processed and recycled, bleeding out as heat. It is a beautiful image. The ferocious, violent monster that ate the world has become a gentle, dying ember, keeping the dark warm for just a little longer. Back in your room, the air is warm, the light is steady. You are living in the prime of the universe. We are lucky. We are alive in the brief, golden window when the universe is hospitable, when energy is abundant, when the sky is full of interesting things. We should cherish this. We often complain about the passage of time, about how fast the years go, but compared to the Google years of the dark era, our lives are a spark so bright and so fast that it is almost instant. We are the fireworks of the cosmos. The concept of entropy states that disorder always increases, things break down, energy spreads out. The universe moves from a state of order, the Big Bang, to a state of chaos, the heat death. The black hole is an engine of entropy. It takes organized matter, planets, stars, people, and grinds them into pure, disorganized radiation. It is the ultimate recycler. But there is dignity in this. We are not just disappearing. We are becoming the background radiation of the future. We are becoming the texture of space itself. As the eons pass, the black hole shrinks further. It becomes the size of a mountain, then the size of a house, then the size of a proton. As it gets smaller, the evaporation becomes violent. The slow leak becomes a stream. The stream becomes a roar. The black hole is destabilizing. It can no longer hold on to its secrets. The gravity that once held a solar system hostage is weakening. The prison walls are getting thin. We are approaching the end of the black hole's life, the moment when the long exhale turns into a final gasp. Physics suggests that the final moments of a black hole are explosive. All the remaining mass is converted into energy in a fraction of a second. It is a flash of gamma rays, a final burst of light in the dark universe. A last statement that says, I was here, but we are not there yet. In this chapter, we are still waiting. We are drifting in the long, quiet middle. This is the hardest part of the journey for the human mind, the waiting. We are creatures of action. We want the climax. But the universe is mostly waiting. It is mostly empty space and empty time. Learning to sit with that emptiness is a form of meditation. It is a way of aligning your mind with the true tempo of reality. So, let's rest here in the deep time. Let's find comfort in the slowness. The black hole is protecting us. It is holding the memory of Earth safe within its event horizon, carrying it like a locket through the centuries of the dark. We are safe in the belly of the beast, and the beast is sleeping. Take a slow breath. Inhale the present moment. Exhale the anxiety of the future. You are here. You are now. The black hole is just a story in your mind, but the peace you feel, that is real. That is yours. The ability to imagine eternity is a gift of human consciousness. We are small, yes, but we can hold the whole timeline of the universe in our thoughts. That makes us large. That makes us infinite in our own way. As Chapter 8 draws to a close, we can sense the change coming. The black hole is getting unstable. The temperature is rising. The slow decay is speeding up. The frozen star is beginning to thaw. The information trapped inside is pushing at the door. The final release is inevitable. We will drift there soon, but for now, float in the timeline. Float in the billions of years. Let the silence wash over you. It is the silence of the cosmos at rest. Welcome back to the final moments of the long watch. If you are just joining us, we have been drifting through an eternity of silence. We have watched the black hole, the great devourer of our solar system, slowly leak its life away into the cold vacuum of the distant future. We have waited through the death of the stars, the fading of the galaxies, and the cooling of the cosmos. For eons, nothing happened. The black hole was just a dark speck in a darker void, hoarding the mass of the earth and the sun, breathing out a faint, cold mist of particles. But now the tempo is changing. The laws of physics dictate that as a black hole loses mass, it gets hotter, it gets brighter. The slow, sleepy decay of the last chapter is waking up into a fever. Tonight, we witness the death of the monster itself. We ask the question, what happens when the prison breaks? And we discover that the end of gravity's reign is not a whimper, but a flash of blinding, purifying light. Chapter 9. The Last Flash of Light. To understand why this moment is inevitable, we have to look at the peculiar math of the event horizon. A black hole's temperature is inversely proportional to its mass. This means that a massive black hole is cold, colder than deep space. But as it shrinks, shedding its mass via Hawking radiation, its temperature begins to climb. At first, the climb is imperceptible. It takes quadrillions of years to rise even a fraction of a degree. But the process is exponential. It feeds on itself. The smaller the hole gets, the faster it radiates. The faster it radiates, the faster it shrinks. And the faster it shrinks, the hotter it gets. It is a runaway train. We are now at the end of the track. Imagine we are floating safely in the void, watching the remnant of what was once the singularity that ate our home. It has shrunk from millions of miles wide to the size of a mountain, then to the size of a boulder, then a grain of sand. As it crosses these thresholds, it stops being invisible. It begins to glow. First, a dull red ember in the absolute darkness of the dead universe. Then, a searing orange. Then, a blinding blue-white. It is no longer a black hole in the visual sense. It is a white-hot speck of pure energy, raging against the dying of the light. This object, now smaller than an atom, is heavier than a mountain. It is vibrating with the intensity of the forces trapped inside. We are witnessing the conversion of matter back into energy on a total scale. Einstein's famous equation, E=mc2, tells us that a tiny amount of mass contains a tremendous amount of energy. The black hole is now unlocking that equation in reverse. The mass of the Earth, the Sun, the planets, compressed and stored for aeons, is being released. But it is not coming out as rocks or water. It is coming out as hard radiation, gamma rays, X-rays, high-energy particles that haven't been seen since the Big Bang. There is a profound tension here. We often think of black holes as holes, empty spaces where things fall in. But right now, it acts more like a seed pod that is about to burst. The information paradox, the question of whether the memory of the solar system was destroyed or preserved, comes to a head here. Some physicists believe that as the black hole evaporates, the information is returned to the universe, encoded in the radiation in a scrambled, chaotic form. If this is true, then we are not being destroyed. We are being broadcast. The data of humanity, of our biology, of our history, is being transmitted out into the void as a burst of quantum noise. We are becoming a signal. As the black hole shrinks to the subatomic scale, the size of a proton, it becomes unstable. The physics of gravity and the physics of the quantum world are now fighting in a space smaller than we can measure. The horizon is trembling. The containment field is failing. The temperature has reached billions of degrees. It is brighter than any star that ever lived, concentrated into a point with no dimensions. The silence of the deep future is about to be broken. And then it happens. The final 10 orange 19 seconds, the last gasp. The black hole can no longer hold itself together. It explodes. This is not a chemical explosion like dynamite. It is a rupture in the fabric of space-time. The remaining mass vanishes in a single pulse of gamma rays, equivalent to the detonation of millions of nuclear bombs. It is a flash that illuminates the darkness for light years in every direction. For a brief moment, the dead universe has a heartbeat again. The energy ripples out, a spherical wave of pure light expanding into the vacuum. It washes over the emptiness where galaxies used to be. It is a funeral salute, a final, "I was here." Let's slow down this moment in our minds. In the flash, the last vestiges of the solar system are liberated. The gravity that crushed us is gone. The singularity that held us is gone. We are free. The energy that made up your body, the atoms of the air you breathed, the light of the sun. It is all mixed together in this expanding shell of photons. We have returned to the wild state of the universe. We are no longer bound by form. We are light, traveling at 186,000 miles per second, destined to travel forever through the expanding nothingness. There is a strange joy in this release. Gravity is a kind of tension. It pulls, it binds, it restricts. But radiation is freedom. It pushes, it travels, it escapes. By exploding, the black hole has granted us the ultimate amnesty. We have served our time in the prison of density. Now, we are allowed to become part of the background again. But what happens to the space where the black hole was? When the mass is gone, does the hole remain? No. The dent in space-time snaps back. Imagine a trampoline with a heavy bowling ball in the center. The fabric is stretched deep. Now, instantly remove the ball. The fabric snaps up, vibrating, rippling, until it settles flat again. That is what happens to space. The deep well we fell into in Chapter 6 is gone. The geometry flattens out. The here becomes just another random point in the void. There is no monument, no gravestone, just a flat, silent calm where a monster once lived. This impermanence is the deepest lesson of the cosmos. Even the things that seem eternal, the stars, the black holes, the laws of gravity, are temporary. They are just shapes that energy takes for a little while. The energy itself is the only constant. It changes clothes, from light to matter, from matter to gravity, from gravity back to light. But it never dies. You are that energy. The consciousness that is listening to this story is a pattern of that energy. And just like the black hole, you are changing every second, releasing the past, moving into the future. Let's drift in the aftermath of the explosion. The gamma rays are fading, stretching into longer, softer wavelengths as they travel. The flash is over. The darkness returns. But it is a different kind of darkness now. It is a darkness that has been touched. The ripples of the explosion will travel forever, tiny gravitational waves whispering to the void that something happened here. Wait, is it truly over? Is there nothing left but radiation? Some theories in loop quantum gravity suggest that when a black hole evaporates completely, it might leave something behind, a remnant, a tiny stable nugget of space-time that cannot evaporate any further. A Planck star. If these exist, then the black hole didn't disappear completely. It left a seed, a microscopic crystal containing the compressed information of everything it ever swallowed. Imagine that, a diamond smaller than an atom, floating in the dark, holding the entire history of the solar system inside it. The library of Earth, the memory of the sun, the stories of humanity, all archived in a speck of unbreakable geometry. It would drift forever, a silent witness to the fact that we existed. It wouldn't emit light. It wouldn't interact with anything. It would just be. A cosmic memory stick waiting for a user that might never come. Whether we became light or a remnant, the result is the same. The event is finished. The drama of the what if is complete. We have traced the path from the Oort cloud to the singularity, and from the singularity to the flash. We have seen the worst the universe can do, and we have seen that even the worst eventually turns into light. Back in your room, take a moment to feel the solidity of your surroundings. The walls, the chair, the ground. You are not exploding. You are not evaporating. You are held together by the strong nuclear force and the electromagnetic force, stable and safe. The atoms in your body are not planning to dissolve for a very, very long time. This stability is a luxury. In the grand scheme of things, being a solid object is a rare and beautiful privilege. Enjoy it. Feel the weight of your own existence. It is a gift. The concept of release is powerful for the human mind. We carry so much tension. We worry about the future. We regret the past. We hold on to things tightly, afraid to let go. But the black hole teaches us that holding on is exhausting. Even gravity gets tired. Eventually you have to let go. Eventually you have to shine. The explosion wasn't a tragedy. It was a relaxation, a return to the natural state of flow. As we float in the quiet dark of the post-black hole universe, we feel a sense of closure. The monster is gone. The fear is gone. There is only the vast open space. It is not lonely. It is spacious. It is room to breathe, room to be. But there is one final question, one loose thread in our tapestry. We have talked about the matter, the energy, the information. But what about the observer? What about the consciousness that watched it all? If the universe has no one left to observe it, does it still exist? In quantum mechanics, the observer plays a crucial role. We are the eyes of the cosmos. By imagining this story, by visualizing the end, we have made it real in the theater of the mind. We have given the black hole a witness. We are the universe remembering its own future. As Chapter 9 fades, we are left with the silence of the aftermath. The energy has dispersed. The ripples have flattened. The story of the physical solar system is done. But the story of the meaning of the solar system remains. We have one last chapter to weave. A chapter not about physics, but about memory. About the echoes we leave behind. About the strange loop of existence, where the end is just a mirror for the beginning. Part 10 awaits. The memory of the universe, the ghost in the geometry. We will gather the scattered light and ask, what did it all mean? And we will find that the answer has been with us the whole time, hidden in the very first breath we took. Are you ready to close the book? Are you ready to drift back from the end of time to the safety of your bed? The final lullaby is coming. Welcome back from the end of time. If you have traveled with us through the entire journey, you have witnessed the complete life cycle of a cosmic tragedy and a cosmic miracle. We watched the solar system unravel, the Earth dissolve, the black hole feast, and finally, the monster itself evaporate into a flash of pure light. We have stood at the very edge of existence and watched the screen go white. Now, the light has faded. The gamma rays have stretched into radio waves, drifting silently into the expanding void. The stage seems empty, but in physics, as in life, nothing is ever truly erased. There is a concept that haunts the equations of relativity and quantum mechanics alike, the conservation of information. It whispers that everything that ever was still is, in some form. Tonight, we finish our story not with a goodbye, but with a realization. We are going to look for the ghost in the geometry. We are going to find out why the universe never forgets. Imagine standing on the shore of a calm lake. You throw a stone into the water, it makes a splash, then sinks. The stone is gone from your sight. The splash settles. But the ripples travel outward. They expand in perfect circles, touching the reeds at the edge, moving the floating leaves, changing the surface of the water for miles. Even 1,000 years later, in a strictly mathematical sense, the position of every water molecule in that lake is slightly different because that stone was thrown. The history of the stone is encoded in the arrangement of the lake. The universe is that lake. And our solar system, our black hole, our entire drama was the stone. Even though the mass is gone, converted into radiation, the impact remains. The gravitational waves generated by the black hole's movements, by the collision of the planets, by the final explosion, they are still traveling. They are ripples in the fabric of space-time itself. They will travel forever, moving at the speed of light, passing through galaxies, passing through nebulae, carrying the faint, rhythmic signature of our existence. A civilization 1 billion light years away, 1 billion years from now, could build a detector sensitive enough to feel the tiny stretch and squeeze of space caused by our story. They would look at their instruments and say, something happened there, something massive, something real. We are etched into the geometry of the cosmos. We have become a permanent vibration in the background of reality. This idea brings us to one of the most comforting theories in physics, the block universe. We tend to think of time as a spotlight that moves from the past to the future, illuminating only the now. We think the past is gone, vanished into nothingness, and the future doesn't exist yet. But Einstein's relativity suggests a different picture. It suggests that time is a dimension, just like space. The universe is a giant block of space-time, containing every moment that has ever happened and every moment that ever will happen, all existing simultaneously. In this view, the past is not destroyed. It is simply a location we have moved past, just as a mountain doesn't vanish just because you drove by it. The solar system, the Earth, your life, this very moment, they are all permanent structures in the block universe. They are frozen in the amber of four-dimensional space. The black hole eating the Earth exists there in that coordinate of time. But the Earth blooming with life exists here in this coordinate. Both are equally real. Both are eternal. We don't need to fear the end, because in the grand architecture of space-time, nothing ever ends. It just occupies its specific place in the mosaic. And what about the light? The light from our sun, emitted before the black hole arrived, is still traveling. It is streaming out into the deep universe. Right now, on a planet 65 million light years away, an observer looking at Earth with a powerful telescope wouldn't see the black hole. They would see the dinosaurs. They would see a blue, green, and white marble teeming with life. That image of Earth is traveling through the cosmos like a postcard that never stops being delivered. We are broadcasting our existence to the infinite. We are a ghost made of photons, haunting the sky of every world that has eyes to see. But there is a deeper layer to this memory, a layer that involves you. We asked in the last chapter, does the universe exist if no one is watching? Quantum mechanics hints that the observer is part of the system. By witnessing the universe, we make it real. By telling this story, by visualizing the black hole, by feeling the emotions of the fall. We have performed a cosmic function. We are the universe's way of knowing itself. As Carl Sagan famously said, we are a way for the cosmos to know itself. Think about the atoms in your brain right now. They were forged in stars. They floated in the nebula that became the solar system. They were part of the Earth. And now they are arranged in a pattern that can think, that can wonder, that can imagine its own destruction. You are not separate from the black hole. You are made of the same stuff. The difference is that you are the part of the universe that woke up. You are the consciousness. And consciousness is the ultimate mirror. When the black hole evaporated in our story, it released its energy back into the wild. That energy will eventually cool, clump together, and form new nebulas. New stars will be born from the ashes of our solar system. New planets will congeal from the dust. And perhaps, on one of those planets, billions of years from now, a new collection of atoms will wake up. They will look at the sky. They will wonder about the dark. They will tell stories. They won't know our names. They won't know about Earth or the rogue black hole. But they will be our children. They will be the next verse in the song that we started. The continuity is unbroken. This is the cycle of Shiva, the cycle of destruction and creation, written in the language of astrophysics. The black hole was not a villain. It was a catalyst. It cleared the board so the game could be played again. It recycled the old matter to make fresh possibilities. It is the great cosmic compost, and we should be grateful for it. Without the death of the first generation of stars, the carbon in our bodies wouldn't exist. Without the gravity that crushes, the stars wouldn't ignite. We live because the universe changes. We breathe because the universe flows. So, where does that leave us tonight? It leaves us right here, in the safety of the present moment. The thought experiment is over. The black hole has faded into the realm of dreams. You are back in your room. The walls are solid. The air is still. The gravity is gentle, holding you to the bed like a mother holding a child. Take a slow, deep breath. Feel the air filling your chest. That is the atmosphere of Earth. It is still here. Feel the warmth of your blankets. That is the energy of the sun, captured and kept for you. It is still here. Feel the beat of your heart. That is the rhythm of life, defying the entropy of the void. It is still here. We have traveled to the end of time and back, and the journey has brought us a gift, gratitude. It is easy to take stability for granted. It is easy to forget how miraculous it is that we are not falling into a singularity, that we are not evaporating into radiation, that we are not freezing in the dark. We are here, in the Goldilocks zone of space and time, wrapped in a blanket of air, spinning gently around a kind yellow star. It is a paradise, a fragile, temporary, beautiful paradise. And you are the keeper of this paradise. You are the memory of the universe. Every time you look at the moon, every time you feel the wind, every time you learn something new, you are adding to the richness of the block universe. You are creating a memory that cannot be erased. You are etching your own story into the geometry of space-time. So, let the fear of the dark wash away. The dark is just the canvas. You are the paint. The black hole is just the silence. You are the music. And even when the music stops, the echo remains. The ghost in the geometry is you. As you drift towards sleep tonight, imagine your own consciousness as a light, a soft, steady light that pushes back the shadows. You are part of the great chain of being that stretches from the Big Bang to the final flash. You belong here. You are exactly where you are supposed to be. The universe has told us its story tonight. It was a story of giants, of gravity, of fire, and of ice. But the ending wasn't the explosion. The ending was the peace that followed. The ending was the return to the calm. And that is where we leave you, in the calm. If this journey has helped you find a moment of stillness in a spinning world, I am deeply grateful. We are all travelers here, drifting through the dark together, sharing our little fires. A gentle like or a soft tap on subscribe helps keep this fire burning. It helps me send these signals out to other travelers who might be lost in the noise. And if you have a moment before you drift off, leave a comment telling me where in the cosmos you are listening from tonight. I read them all, and they remind me that I am not speaking to the void, but to a vast, beautiful community of starry-eyed souls. Thank you for trusting me with your imagination. Thank you for walking to the edge of the event horizon and back. The story is done. The book is closed. The stars are watching over you. Until next time, may the gravity be kind to you. May the light be warm upon you. And may the universe turn softly around you.